or cone, something that needs very, very little. Because for resonance, you need almost no power. You need just enough to overcome the resistance in the substrate, in other words, the cone itself. Divide and rule.
That's almost the definition of resonance, isn't it?
It is. Divide and rule. Big chunky base unit, bottom end, let that handle all the power, and then top end, little tweeter, and off you go. Not a bad solution, to be fair. So it became in the 1960s the power game, and of course we all saw it, with the ever bigger sort of juicy MOSFET amps that came out, and it's wonderful stuff. I have a collection from Japan of Onkyos and all sorts of stuff, which I hang on to with great delight. So the full range driver disappeared, almost disappeared in the 1960s. Only a few satellite manufacturers left. Foster Corporation in Japan. Japan is still the home of the full range driver. 50% of what we make goes to Japan. They're into. Japan. You've got relatively small. The houses, flats are relatively small. You've got very close neighbours. 250 watts is a great way to nap off your neighbour. So home full range is still very much a following in Japan, but the rest of the world really moved to multi-way. And just like vinyl was overtaken by CD, and now CD has been overtaken by downloads and music you can download on, all that sort of stuff, although vinyl's coming back. The following for full range has been very niche market and specialist. And full range drivers, going back to the my terrible first flip, full range drivers, traditionally, because you only had a few watts from your whacking great tube amp, didn't do an awful lot in this low range end. So if you look at some very old designs on the internet, type in Lowther or Fostex designs, what you'll find is these big, and Scott will talk about this more, and Steph will, these huge speaker boxes, these massive things that maybe your grandfathers had, and then the speaker in the middle. And they are basically expansion boxes where they're trying to expand the sound, the very, very tiny amount of oscillation that's coming off that driver, to expand it to create a low wave effect, expand that wave, allow it to drop the frequency, and you'll get a bit of a bass sound. But to do it, you need a big box when you've got a traditional full range driver. So you think, okay, so why is it that full range drivers, most full range drivers in those days and today, are good from the middle, lower middle and up the high range, and can't do much at the low range? Well, we're back to the power game, which is when you want a full range driver to do the middle and the high, you have to think about what you're going to do with the amount of energy you have in the middle and the full range and the high range. It's very, very small, measures of microjoules. And so if you've got a whacking great big thick heavy cone sucking up that's mass heavy, and you're only transferring into it just minute amounts of energy at a frequency of 10 kilohertz, it just about will make it off the neck of the coil there, and then it hits a whacking great slab of Kevlar or fiberglass called a cone, and that's it. There's no way you can transfer that amount of small energy into such a large mass. Sorry guys, just the laws of physics, what it is. So full range manufacturers like me, and we'll come into cars and aerospace now, we need very, very low mass thin materials. You can actually feel, this is one of our thickest materials. This is actually 130 microns, this is 1176 magnesium alloy, NASA or aerospace grade material. If we go on, I haven't brought it with me, but if we go into something like the Alpair 10 there, that's 80 microns, that cone is 80 microns thick. Why? Because I got to come back to the Lotus School of Engineering that says, you know, if you want to get something to be very efficient, you want it to move and manoeuvre very efficiently, you've got to deal with this more Jason stuff. You've got to deal with things like power to weight ratio. In my case, I've got to deal with energy loss. So, if I can have a cone that is extremely light but stable, that small amount of energy that I've got, which comes from the middle and high range, I can get it to pass across the surface of that substrate. But that leaves me with a problem. As soon as then I want to build in some low range performance, well, it's like getting a piece of tin foil that you wrap your chicken in. Can you imagine? That's just going to fold up. There's no way something so thin and so delicate can handle, a bit of the old British beef. This stuff, not a chance. So that is an engineering for us guys. Where is Mark? When we're looking at the physical world of getting things to move, whether it's a car, a plane, or a speaker, we're always having to try to extend the mechanical design, and we're always caught between a rock and a hard place. On the one hand, we want to get performance, whether it's sound performance or whether it's speed or whatever it is. And usually, by and large, the general rule, note the word general and let's say guide, is if you want something to stop, go forwards, turn, or in the case of a speaker, go backwards and forwards, then the lighter it is, the better it will perform that task. So, a traditional four-range driver looks like this. Thinking back, we only had back to 40 years ago when four-range drivers were in their zenith, when at the top of the game. You had your whacking great big amplifier with its huge tubes, and you might have about 5 watts per channel if you were lucky. You would have a whacking great large huge box with your driver in the middle of it, and all the driver needed to do, there's a cone, there's a coil, and there's a winding, maybe about 2 millimetres. Why is that? Well, the cone was usually fairly big, so there's a lot of cone surface area, and you've got a whacking great big box, which Scott will talk about later on, and you will be able to take a sound wave and expand it and lower the frequency, and you could do it just a few watts. Along comes a transistor, and suddenly we've got bucket loads of power. And this type of speaker with its very high SPL. Are you guys happy with that? SPL, sound pressure level, efficiency. So when you go on the internet and you want to buy a speaker driver, they'll all come mostly.
My internet site, guys.
Well, you go to Stefan. Go to Stefan. You'll see just like when you buy, when you click on let's go do cars. So you go to the tech specs, and you'll see the dimensions of the car. You'll see the weight of the car. You'll see the engine. It's 1600cc 4-cylinder, X amount of brake horsepower or kilowatts, 0 to 60 and X and all that. You get the same with speaker drivers called Thiel and Small, TNS parameters, just to let you know. And one of the holy grails there is SPL, sound pressure level, which is measured in decibel, dB. Oh, I can't do it. dB, decibel.
Okay.
And that's measured typically the industry measurement is, so I'll be about 1 metre away from you. You're the microphone, I'm the speaker. We're in a soundproof chamber. We give that a sweep test. You're the microphone. You'll pick up, and then you'll get a frequency plot. And from that frequency plot, from low frequency to high, you'll get some measurement in dB, and usually you can then say, yeah, it's 88 dB efficient, it will produce 88 decibels at 1 metre away, and so on and so forth. Full range drivers, because they were never designed to handle a lot of power, and because in the old days you didn't have a lot of power, the more efficient the driver could be at converting electrical energy into sound wave energy, measured in decibels at 1 metre, the more efficient it was, that was the holy grail. Because in those days, just like in automotive, going back to the 1960s, I remember my first 1300, my Mark 1 Escort 1300 GT had 75 or 65 or 70 horsepower. Whoa, that's like bloody brilliant. On 18 years, 70 horsepower. You know, Christ, little bloody Golf Polo chucks to that now from a 1 litre 3-cylinder engine, doesn't it? I mean, you know, so things have changed a lot. So, traditional 4-range drivers have really been caught in a time warp. If you buy a traditional 4-range driver today, it still has that very, very short coil, so the cone doesn't move hardly at all, barely a couple of millimetres if you buy a Fostex, not even that.
One is to 1.5.
They're time warp drivers. And so in comes this stupid old git from, namely Mark Fenlon, from the speaker industry, comes out of Salford University with his certificate, and then goes to spends a bit of time in industry, comes back, changes tack, goes to medical school and becomes a doctor, and become a public health specialist. Did that for 12 years, and then went back into industry in China. Packed my bags, stuck a pin in a map, and lo and behold, I'm in a place where, when you walk into a factory in China and Taiwan and so on, and you say, "Can you?" and they stop you, and they use the word "doi." Let's say D-U-Y, doi, which means yes. Do you think, yeah, doi? Could you, doi? The answer is yes. They'll make anything, almost anything. Very, very different culture to what we have in Europe, where we think, don't know if we can do that, you know, that type of culture, except for ProDrive. And I thought, hang on, this is nuts. You know, let's just think about this. You know, we've got all this modern technology, we've got wonderful materials that we can use now. Well, can't we make a 4-range driver do low range? I'm bloody sure we bloody can. So I was convinced. You know, I thought, this is just a standard, fairly, I wouldn't say straightforward, but it's a, you know, it's a design exercise. What we need is a big coil with a long winding, but we just need to make the thing low mass. We really need to get the mass down on the back end of this driver, and then when we get to the front end here, we need to think about what materials we can use that are low mass but have relatively high tensile strength, and in the manufacturing process can be made relatively rigid. Okay? And actually, you know what? This is where this country's good. We're good at this sort of stuff. So this Pluva 11, which you, if I take the central spacer out, how many of you always, I'll tell you what, let me hand that round without the central spacer in it. Because what you're looking at is, and what it's got there, hang on, let me do the other one. And then I'll, let's say, honestly guys, please do go to questions, queries, anything. If you put that on some scales, it's just a few grams. I mean, forgive me because I haven't had a chance to weigh it. I know the component values, but the actual power, that's a power. You see, I call that a powertrain. And the rest of the audio industry think I'm nuts. Well, I'm not, because any other industry, cars, aerospace, because that's the central hub of the sub-assembly of the. That's the central sub-assembly, and it moves. So that is a powertrain sub-assembly. The audio industry doesn't even think like that. As I said, I'm not from the audio industry. But I think we'll all agree as you pass that round, it is not very heavy. If you were to pull out the powertrain sub-assembly from a 5.5 or 6 inch typical mid-bass drive that you can buy, possibly from Stefan, that just as the low range, it'd probably be about twice the mass of that. So that's really it. I spent the last 10, 15 years working out how to, I don't know how to draw it, that one, how to do this. To basically take that super duper delicate old traditional driver design full range and make it more stable in an engineering production terms. So now what happens is that coil gets longer, so we are able to allow for LF oscillation. But at the same time, thinking about cars, we don't want that sub-assembly to get any heavier because it still has to resonate for the middle and the high range. So that is the fundamental difference between a Mark Audio driver and a traditional full range driver.
Got
Yeah.
you mentioned earlier about the edge of the cone being your suspension in terms of
Yeah.
Would softer suspension give you more leeway for lower
Absolutely
frequency?
correct. So, sorry, we got. Oh, thanks. So, if you now come the trade secrets. So, well, yeah. So, okay. Typical. This is a traditional driver in the sense that it has a front suspension which we call a surround or edge in the trade. If you go into a factory and start talking to speaker guys and all the audio guys say, oh, it's a surround. But I promise you, if you go into a factory, and where I live in Hong Kong and South China, in Guangdong province, we produce 4 billion transducers per year. 4 billion, not 4 million, 4 billion. That's an edge, not a surround, but don't worry about that. So, in short answer, if you just feel that,
Yeah.
sort of heading into condom country. Okay. Whereas, actually, it's pity. Actually, Stefan, I should have brought. It's my fault. Next time I remember, I'll bring we'll bring a couple of traditional.
I've got some other Mark's drivers. In fact,
no, I was thinking on future talks we'll bring a sort of atypical
I've got a couple of
base
Fostex
mid
left
unit.
And PCs units.
Yeah, if we were to rip the guts out of a typical, say, 5-inch bass driver, you'd notice a huge difference. You've got it in one. You'll notice that front edge or surround is thicker because it needs to handle more power. The spider, the rear suspension, which gives linear stability to the movement, you'll find it's big, thick and heavy. If you look at a Mark Audio spider and hold it up to the light, you can see right through it. It's that thin. Can you see?
Off the top of my head, Matt, as I was looking at the Blueberry 11 PDF earlier, you're looking at a total powertrain mass there of about just under 6 grams.
Correct.
Now, your
That's
typical
super light.
Yeah, your typical 5.5-inch mid-bass.
12, 15
C's,
grams.
Scan speed, yeah, 12 to 15. Double
the weight.
more than double.
Mm.
And that is a profound difference.
Mm.
These little 4.5-inch drivers in these are about 11.4
Yeah.
grams. So they're
Yeah.
about the same size
Double.
as those.
Double the weight.
Does that include the coil and spider
Yeah.
and everything?
Yeah.
Or is it just
That's
like-
everything
it's
that
a
moves. Moving
mass,
mass.
powertrain mass.
Right, okay. Effectively, it's just the
Yeah,
sprung.
if you see it listed in field small specs,
Yeah.
it's not actually a field small spec at all. It existed well
Yeah.
before that. It's listed
Moving
as
mass, it's
moving
called.
mass.
Just for your own interest, moving mass.
Really.
Okay.